Assalamu alaikum dear students. I hope you all are fine. Today we are going to discuss our new topic, how do metals and non-metals react. So all of you know that metals are the elements that are electropositive in nature. It means they have tendency to lose their valence electron because in their valence shell the electrons are unpaired. The metals are unstable in nature. In the same way, non-metals are also unstable in nature. They are electronegative, that is, they have the tendency to gain extra electrons. So metals and non-metals react with each other by the loss and gain of electrons because both are unstable in nature, and in order to gain stability they react with each other. And when they react with each other they form ionic compounds. They form ionic compounds which contain ionic bond. So you must know what is ionic bond, and before discussing it I would like to tell you the meaning of chemical bond. As you know that when two substances react with each other, when one chemical substance reacts with a new chemical substance, they lead to the formation of a new substance. That is, I will give you a general example. For example, A when it reacts with B. These are the two chemical substances. They react with each other and they lead to the formation of a new substance, that is AB. These two substances are reactants and AB is a product. And you know that A and B are linked with each other by a chemical bond. They contain a chemical bond which holds them together. So chemical bond means when atoms of elements combine with each other to form molecules. A force of attraction is developed between the atoms which holds them together, and the force which links the atoms in a molecule is called a chemical bond. It is the force of attraction that links the two substances with each other. So one atom reacts with other atom. When two elements take part in a chemical reaction, it is the atoms of those elements that react with each other, and the atoms contain subatomic particles, and the electron is the subatomic particle that takes part in a chemical reaction. The substances are formed by the loss or gain of electrons. All the elements that are present in the periodic table except noble gases. Here you know that inertness of noble gases, or they are also called as inert gases. All the elements are reactive in nature, but noble gases are non-reactive. It means all the other elements that are present in the periodic table, they contain incomplete valence shell. Valence shell means outermost shell. They contain incomplete valence shell. That is why they take part in a chemical reaction in order to gain stability. And you know that the noble gases, that is helium, neon, argon, krypton, xenon and radon, they don't react with other elements to form compounds because only outermost electron take part in bond formation or in chemical reaction, but noble gases contain all the electrons in the valence shell. The valence shell of noble gases is already complete. You know, just look at the picture. Helium, its atomic number is 2. Neon, its atomic number is 10. You are watching here the electronic arrangement of the noble gases. All the elements contain 8 electrons in their outermost shell, except helium. It contains 2 electrons in its first. This is the outermost shell of helium as well. So electron arrangement is stable in their atoms. They don't need to lose or gain electrons because they are already stable in nature. All the other elements are unstable. That is why they react with each other in order to gain nearest noble gas configuration in order to become stable. But noble gases are already stable, so they do not participate in bond formation. Here you see helium contains 2 electrons in its outermost shell, and the element that contains 2 electrons in its outermost shell, that is called as duplet, to have 2 electrons in valence shell. So example is helium, and all other noble gases from neon to radon, they contain 8 electrons in their valence shell, so it is called its octet. So noble gases exhibit duplet as well as octet. That is why they are unstable in nature and they are chemically non-reactive. So what is the cause of chemical bonding? The cause of chemical bonding or chemical combination is stability. Why do metals and non-metals, or why do any element take part in a chemical combination or in a chemical bonding? It is because of its stability. It is the main reason. The elements needs to become stable. Each and every elements want stability. It wants to have the electron arrangement of an inert gas. I will show you an example. For example, lithium, its atomic number is 3, so its electronic configuration is 2 and 1. In K shell it contains 2 electrons, and in L shell it contains 1 electron. Helium, its atomic number is 2, so in K shell it contains 2 electrons. What is the difference between the two? One is stable and the other one is unstable. One is chemically reactive and the other one is chemically non-reactive. So which one is stable? Helium. It is stable because K shell contains only 2 electrons. In K shell there must be a total number of 2 electrons, and it is having the 2 electron, so it doesn't need to lose or gain any electron. But in lithium its valence shell is L. It must contain total number of 8 electrons, so it is short of 7 electron. That is why it will lose 1 electron. It will lose this valence electron, and after losing its electronic configuration becomes 2. The number of electrons that are left in the lithium, that is 2. So its electronic configuration is matched with the helium. Hence it becomes stable, and it becomes stable only when it loses an electron. Next example, fluorine. It is a non-metal. Its atomic number is 9. Its electronic configuration is 2 and 7. K shell contains 2 electrons and L shell contains 7 electrons. And let me take an example of a noble gas, neon. Its atomic number is 10. It is having 2 electrons in K shell and 8 electrons in L shell. It is chemically stable because L shell is already filled, but in fluorine L shell contains 7 electrons. It is short of 1 electron, so in order to become stable it will gain an electron, and its electronic configuration will be matched with the electronic configuration of neon. So by these examples we understood that noble gases are stable in nature, and all the elements, whether it is a metal or a non-metal, it reacts with other elements in order to gain nearest noble gas configuration or inert gas electron arrangement. So this is the reason behind the chemical reactivity of metals and non-metals. So how does an atom achieve noble gas configuration? It can achieve noble gas configuration in three ways. First one is by losing one or more electrons to other atom. When an element reacts with other element, it loses its one or more electron to become stable. Second, by gaining one or more electron. When an atom gains one or more electron from any other atom, this is the second way. And number third is by mutual sharing of electron with other atom. When an element shares its electron mutually with the other atom, it gains its stability. But here you will note it down that inert gas configuration is achieved only by the loss or gain of electron between metal and non-metal. By mutual sharing of electron, an atom becomes only stable. But when a reaction takes place between a metal and a non-metal, the atoms achieve the nearest noble gas configuration when they lose or gain electrons. So when elements lose or gain electron, you know that metals lose electron and non-metals gain electron. When any metal or non-metal lose an electron or gain an electron, they form a new substance which is called as ion. They form an ion. You know that an ion is an electrically charged atom or group of atoms formed by the loss or gain of electron. You know that when an element is present in its elemental form, it is electrically neutral. That means I will show you. For example, hydrogen, its atomic number is 1. Sodium, its atomic number is 11. So hydrogen as well as sodium are neutral in nature. All the elements that are present in periodic table, they are neutral because they contain the number of protons and electrons in any neutral atom is equal. That is why they are neutral in nature. For example, hydrogen, its atomic number is 1. It means it contains one proton and one electron. Proton is having positive charge and electron is having negative charge. So the number of positively charged particles is equal to the number of negatively charged particles. So the substance or the element is neutral in nature. In the same way, atomic number of sodium, it's 11. It means it contains 11 protons and 11 electrons. So negative, it contains positive charge and it contains negative charge. The number of positively charged subatomic particle is equal to the number of negatively charged subatomic particle. So that means sodium is also neutral in nature. In the same way, all the other elements that are present in the periodic table are neutral in nature. But when elements either lose or gain electron, they become electrically charged. A charge comes over them, whether it is positive charge or it is negative charge. So ion is any electrically charged atom or group of atom formed by the loss or gain of electrons. It is having two types. First one is cation and second is anion. Cations are the positively charged ions that are formed by the loss of electron, and anions are the negatively charged ions formed by the gain of electron. I will show you a general example. For example, A, it is an element. For instance, its atomic number is 5. So it contains 5 protons and 5 electrons. It is electrically neutral. But when it loses an electron, when it loses an electron, a positive charge is developed on it. Why? Why is positive charge developed on it and why not negative charge? I will show you how. When the element is neutral, it contains 5 protons and 5 electrons. Protons are having positive charge, electrons are having negative charge. It is equal, so it is electrically neutral. But when an electron is removed from this element, number of protons remain same, but the number of electron is decreased by 1. It contains 4 electron. So here 5 positively charged plus 5 and minus 4, 5 protons and 4 electron. Just solve it. It is a shortcut. Just solve it. Plus 5 minus 4, it will become plus 1. So a positive charge is developed on this element. If it loses 2 electron, I will show you example. A, its atomic number is 5. If it loses 2 electron, it develops 2 positive. The number of electrons lost are directly proportional to the number of positive charges that comes on this element. 5 atomic number means it contains 5 protons and 5 electrons. But when 2 electrons are lost, only 3 electrons are left, but number of protons are same. So plus 5 minus 3, it becomes plus 2, plus positive charge. These are the examples of the elements, or these are the examples by which a neutral atom is converted into a cation. Plus 2, that means divalent positive, plus 1 monovalent positive, in the same way plus 3 trivalent positive. So an atom can lose 3 electrons, from 1 to 3 electrons. These are the examples of cation. Now I will show you how is negative charge developed on an anion. Same way, A, for example, its atomic number is 9. 9 atomic number means 9 protons and 9 electron. In order to become stable, it will gain an electron. When it gains an electron, a negative charge is developed on it. How? This is neutral. At first it was a neutral element because the number of positively charged subatomic particles are equal to the number of negatively charged subatomic particles. The number of protons is equal to the number of electron. But when it gains an extra electron, number of protons remains same, but the number of electrons are increased from 9 to 10. 10 electron. Electron contain negative charge, proton contain positive charge, so plus 9 minus 10, it will become minus 1. So the number of electron gained is directly proportional to the number of negative charges that are developed on this atom. So these are the examples which show how positive and a negative charge comes on a neutral atom. Now I will show you some examples of metals and non-metals, how they lose electrons and how non-metals gain electron. So first metal is lithium. Its atomic number is 3 and its electronic configuration is 2 and 1. K shell contains 2 electrons and L shell contains only 1 electron. So L shell must possess a total number of 8 electrons. So here you know that it is short of how many electrons? It needs 7 electrons to become stable, so that its electronic configuration will be matched with the nearest noble gas. But it is impossible to gain 7 electrons. An element can gain a maximum of 3 electrons. So it cannot gain 7 electrons. So in order to become stable, it will lose this 1 electron. So lithium minus 1 electron, because L shell contains only 1 electron. So when it loses this 1 electron, it becomes positively charged species. It becomes lithium cation. At first, when it was neutral, its electronic configuration was 2 and 1, but when it loses this 1 electron, its electronic configuration becomes 2. The number of electrons left in the lithium cation are 2. And which noble gas contains 2 electrons? That is helium. Its electronic configuration matches with the electronic configuration of helium, hence it becomes stable, and it becomes stable only when it loses 1 electron. Next example is sodium. Atomic number of sodium is 11. Its electronic configuration is 2, 8 and 1. K shell, L shell and M shell. M shell must possess a maximum of 8 electrons. So in the same way, it is short of 7 electrons. So in order to become stable, it will lose this 1 electron and it will get converted into Na positive. At first its electronic configuration was 281. Now its electronic configuration becomes 28. So it is left with a total number of 10 electrons, and 10 is the atomic number of neon. So neon is its nearest noble gas, so it becomes stable. Next example is magnesium. Its atomic number is 12. Its electronic configuration is 2, 8 and 1. Sorry, its electronic configuration is 2, 8, 2. K shell, L shell and M shell. M shell must contain 8 electrons, so it is short of 6 electrons. In order to become stable, it will lose these 2 electrons and it will get converted into Mg2 positive. Its electronic configuration becomes 2, 8 when it loses these 2 electrons. So a total number of 10 electrons are left in it, and 10 is the atomic number of neon. So whether a metal gains +1 charge or +2 charge or +3 charge, their electronic configuration is matched with those of the noble gases. I will show you a last example in which a metal loses its 3 electrons. Aluminium. Its atomic number is 13. Its electronic configuration is 2, 8 and 3. K shell contains 2 electrons, L shell contains 8 electrons and M shell contains 3 electrons. So M shell must possess 8 electrons. So it requires 5 more electrons, but it's impossible to gain 5 electrons. That means it will lose these 3 electrons, minus 3 electron, and it will get converted into Al trivalent positive aluminum cation. These 3 electrons are lost and its electronic configuration becomes 2 and 8, total number of 10 electron. This is the atomic number of neon. These were some examples of metals by which they lose their electron. So here you know that neutral, here it is neutral element, and neutral element contains unstable electron arrangement. In here, when it becomes cation, it gains its stability. Now let me show you some examples of anions. First example is chlorine. Its atomic number is 17. Electronic configuration is 2, 8 and 7. K shell contains 2 electrons, L shell contains 8 and M shell contains 7 electrons. M shell must possess how many electrons? 8. I have repeated it so many times. It is short of how many electrons? It requires only 1 electron to become stable. It can easily gain this electron. So plus, when it gains 1 electron, it gets converted into Cl negative. Its electronic configuration was 2, 8 and 7 when it was present in its unstable form or neutral form, but when it gains an electron, its electronic configuration becomes 288. So a total number of 18 electrons, and 18 is the electronic configuration of which noble gas? Argon. It becomes stable. Next example is oxygen. Atomic number of oxygen is 8. Its electronic configuration is 2 and 6. L shell must contain 8 electrons. It requires how many electrons to become stable? 2 electrons. So it is a non-metal and it is having the quality of gaining electrons. So when it gains its 2 electron, it gets converted into oxygen divalent negative. When it gains its 2 electron, its electronic configuration becomes 2 and 8. So total number of how many electrons are left in it? 10, and 10 is the atomic number of neon. Whether an element loses its electron or gains electron, its electronic configuration is matched with the electronic configuration of noble gases, because noble gases are the only elements in the periodic table which are stable. Let me show you last example. Nitrogen. Its atomic number is 7. Its electronic configuration is 2 and 5. K shell contains 2 electrons and it is valence shell, that is L shell contains 5 electrons. So it is short of how many electrons? 3 electrons. As I told you earlier that a metal can lose electrons from 1 to 3, in the same way a non-metal can gain electrons from 1 to 3. So it requires 3 electrons. So easily it can gain 3 electrons and it will become nitrogen trivalent negative. At first its electronic configuration was 2 and 5. When it gains 3 electrons, its electronic configuration becomes 2, 8. So total number of electrons are 10, which is the atomic number of neon. So whether a metal loses electron or whether a non-metal gains electron, they require or they attain the nearest noble gas configuration. So this is the formation of positive ions and negative ions. So in the next class we will discuss how these positive and negative ions react with each other to form ionic compounds.